Human water consumption is soaring to levels greater than rivers and groundwater can sustain. The result is a water gap and depletion which threatens humans, ecosystems, and wildfire. In this video, you'll learn about a cool new data set that shows the water gap globally. You'll also see how you can access data with Python to create your own charts and visualization. The World Water Map is a new tool that promotes water literacy. It shows the output of a model that forecasts the risk of watersheds drying up and dwindling water supplies. It's based on a global model developed at Utrecht University by a team led by Mark Bierkens. It's presented in an application that makes the underlying data available for researchers, policymakers, journalists, and others interested in a deeper dive into the problem. It helps us understand where and why the water gap arises, how it might be aggravated, and how it might be managed. Browsing through the app, you can see how the world's water gaps have developed since 1980s, explore how they might evolve under different scenarios of climate change and economic development, and download the data to analyze yourself. I'm going to show you how you can access the data to create your own charts and visuals so you can use it in your own narratives. We will use Python and standard open source libraries in a shareable Google Colab notebook, available for you to duplicate and run on your own. But before we jump in, let's think about why this matters. Being able to run your own analysis with open source tools is important. First, it lets you customize analysis to fit your own questions about water availability on the map. It also enhances transparency by independently verifying water stress projections. And finally, it lets you integrate with other datasets to form a more comprehensive understanding of water-related risks. Now let's jump into the app. Browse the Insights app link below. Navigate to your area of interest. For instance, let's go to Mexico. I can see a time series of the nation as a whole or a breakdown by province. I can also download a chart as an image and see a summary. It says here that the total water gap in 2019 for Mexico is 63 cubic kilometers. That's about 25 million Olympic swimming pools. I can click the blue widgets above to change the variables that I showed on the map and click through and see a couple scenarios. But how can I ask my own questions to the data? For that, we're going to use Python to access the data and create our own charts. First, click the download button. I will copy the URL that lets me download the data directly with Python. Right-click and select Copy Link Address. Now let's take the data to Python land. To follow along, you may open the Link Colab, which is a Jupyter Notebook environment where you can run your own data science Python code for free. Here's the workflow. First, we're going to download files. The data comes as a zip file, so download it and unzip it with this snippet. The output data will look like these associated files. The most important directories to keep in mind are the rasters and the vector tables. We can explore the file directory, and for a quick glance at the data, we can create a simple table and plot. Let's copy this file path, and we can use a pandas data frame library to read the CSV files as a table. We see here that the columns for country, variable name, year, and the value. In this case, we're looking at the total water demand at the country level for Mexico. We can also make a quick plot with the matplotlib library. It shows an increasing trend, and we can confirm visually that it matches the shape of the plot shown in the app. But what if I want to examine different variables simultaneously? For a more complex plot that is also interactive, we can create a time series chart of a handful of variables. In this case, we're going to use historical demand, withdrawal, gap, and abstraction. Let's list the files. Now we can open them with pandas and put them all in the same table. Now we can use the Plotly library to create a stacked time series of water usage. I can hover over the plot to see individual values for each variable year by year. Plotly also lets me download as a PNG image. But now, what if I want to place the data on a map? I can use the raster image that shows a heat map and a polygon with an outline of the country. For this example, I'll grab the historical data for 1980, but you can use any of the TIFF files in the directory. I'll use the leafmat library to create the map. First, create a map, add a base map, add the raster layer, and the vector layer. Here I can see the layer explorer, and I can start dimming the historical demand. It lets me visually inspect the TIFF file in an interactive, intuitive way. But now, what if I want to see the difference between 2 years? I'll use the whitebox library to subtract the total demand in 1980 from 2019 and see the difference. And just like we did above, I can now dim the layer and zoom to the hottest spot, which is where the demand increased the most between those 2 years. I can see from this map that the hottest zone is Mexico City. It's where water demand increased the most between 1980 and 2019. That's it for this video. You learned what the World Water Map is, how to access its data with Python, and how to perform basic analysis and create visualizations. I look forward to seeing the analysis and narrative that you create from this dataset.